Okay, welcome to Friday's class. This is assignment one in the statistics unit. I'm going to give you work time in class. I stay on the blog. So what I'm intending to do is every 2 or 3 or every 10 minutes, I'll go over 2 or 3 of the questions. So by the time I get to the end of the class, I'll have gone over all of assignment one, just so you don't have any issues with it. If we finish a bit early, then I will begin lesson two. And if not, we'll just kind of end it there. So I did state that this was a work class on the blog, so I'm going to honor that. And you can chime in on live chat if you have any questions at all for me. Okay, I'm going to do number 1, maybe 1 to 3, and then give you a bit more time to work. So if you're watching this later, I mean, you could always speed up the video if you've done this and check your answers. But I know that this is historically, it's one of the units that our students have a lot of problems with. So I want to take my time on probability and really make sure that people have the opportunity to try these questions on your own. That's why I thought I might take a different approach today and just do little, like, chunk out the work. So this was actually sent a couple of days ago. I think this is probably pretty straightforward. I read the word 17 out of 23, and I know that I could write that easily as a fraction, right? I can write it as 17 out of 23. I know how to convert that to a decimal. I just take my calculator, and this is the division bar as well as being the ratio separating the fraction. So 17 divided by 23. And remember, we're always rounding to 2 decimals, so that would round to 0.74. Okay, and then how do I get from here to here? Now, this is the tricky part. Because this is a 2 decimal course, everything has to be in 2 decimals. I'm just going to hold my calculator up, and I hope you can, there, it's a little better, right? So I have to leave the whole decimal number in my calculator and then multiply by 100. And that gives me a percent of 73.91. Be very careful about that because we want the 2 appropriate decimal numbers. So this one had to be rounded, but you have to keep the whole number in your calculator when you multiply by 100. Otherwise, you're going to have an incorrect percent. I don't want to see a 74% here. That would be rounded to too much. Our percent, or the decimal number, I know I could easily multiply that by 100, right? And I get 58%. Okay, and I also know that a percent number is always the percent number written as a fraction out of 100. Okay, so that's an easy way to convert to a fraction. And then I guess I would say 58 out of 100. Okay, 68 out of 90. My calculator tells me, now once again, it's this repeating decimal, so I have to keep the whole decimal number in my calculator. I'm going to record the proper 2 decimal answer, but I keep it all in my calculator, and then I multiply by 100 to give me 75.56%. Okay, and this, the words, what they want is the word, whatever's given to you, right? I guess the fraction. So 68 out of 90. Gives you practice writing numbers out. 49%, okay, well, I know that's the 49 is the fraction 49 out of 100. That, if I do my division, I get a 0.49. And this is 49 out of 100. Okay. 13 divided by 27 gives me 0.48. But when I leave the whole decimal in my calculator and then I multiply by 100, I get 48.15. And then finally, 13 out of 27. Okay, so as long as you remember, I mean, I think that we've done enough work in the past with fractions and percents that this is probably pretty straightforward to you. I think the tricky part is making sure that you leave the decimal number in your calculator till after you multiply by 100. Otherwise, your decimals will be wrong in your percents because this is a 2 decimal course. Now, when it's 0.00, you don't have to bother putting the 0.00. You can just end your percent as whatever the percent number is. Let's take a look at number 2. John tosses a coin and finds that it shows up heads 5 times in a row. Will it show up heads on the 6th try? Why or why not? Okay, the answer to that is it might not show heads on the 6th try, on the 6th toss. Okay, why or why not? There's a 50% chance. There's only a 50% chance it will be heads. Now, 50% is a lot, but it's not 100%, right? They're basically asking you, is it a 100% chance it'll be heads just because it's shown heads? No, not if it's a fair coin. There's still only 50% chance it's going to show heads. Okay, I'll do number 3, and then I'm going to take a 10-minute break again and let you work on the next 3, 4, 5, 6. Pierre takes the bus to school. He notices that 80% of the time, the bus is at least 5 minutes late. Should he plan to arrive late to his bus stop each day? Why or why not? Okay, well, most of the time the bus is late, but no, he should arrive on time. The bus is still on time 20% of the time, right? The bus is still on time 20% of the days. And you can't predict which day the bus will be late, which day the bus will be on time, or even if the bus will be late. Maybe there was a problem with the bus and it gets fixed and it's on time forever. So that's the thing with probability. You think you know what's going to happen and you can predict what's going to happen, probably, but you can't say for certain. All right, I'm going to stop for another 10 minutes and I'm going to give you 10 minutes to work on 4, 5, and 6. And if you finish that up, you can keep working on, just keep going, okay? Okay, let's keep going. I left at number 3, so let's talk about number 4. So number 2 and number 3, number 1 was basic skills, right? You should be able to convert from a fraction to a decimal to percent, no problem. I wouldn't worry too much about writing out in English. Number 2 and 3 are just getting the point across that you can't ever say for sure what will happen, even though you have a really good idea of what will happen, like probability. If you study past historical events, you might have a pretty good idea what's going to happen, but with probability, you can't really know for sure, right? So let's talk about number 4. The radio states that on a certain day, the probability of rain is 90%. If you walk to school, should you bring an umbrella that day? Why or why not? Well, yes, I think you should. Yes, you should. You have to use probability as a guide for life and for living. It will probably rain. It will, sorry. If it doesn't, big deal. You've taken your umbrella on for you've thrown your umbrella in your bag, no big deal. Now, we don't know for sure, we don't know for sure if it'll rain, but it probably will. So take your umbrella. Okay. Number 5, the probability of snow one winter day is 45%. State the probability that it will not snow on that day. All right. So this is called the complement. Okay. The probability it will not snow is, all right, so if it snows 45%, so to figure out not snow, I take my 100%, because that's the total probability of all events that can happen, or of the snow, not snow. And I take away the probability that it will snow. So this is my final answer. My answer probability is not snow is 55%. That's how I figure out the complement. Okay. This is called the complement. That word complement looks kind of like the word complete is found inside complement, and it's the leftover that would complete the whole set. The whole set of the events of snow and not snow is 100%. So if I take the 45 out, we're left with the 55%. Right? So let's see. So if you're given a probability of an event and then you're trying to find the probability of the opposite of that event, it's the complement. An all-star player hits the ball 12 out of 20 times that he goes up to bat. State the experimental probability that he does not get a hit when he goes up to bat. So this is the experimental probability he gets a hit. So the number of times he does not, so again, this is the complement they're asking for, get a hit, is 8. So therefore, the probability of not hitting, now probability means we put it into fraction form, right, equals, well, 8 out of 20 times. It's the leftover, right? If 12 out of 20 he gets a hit, the remaining times he doesn't get a hit, 8 out of 20. Hi, Cynthia. Nice to see you. I was wondering what happened to you. I haven't talked to you in a couple of days. So I'm glad that you're here with me. It makes me, and I see someone else's too. It's nice when you guys chime in so I know who I'm spending time with. Okay. Let's do one more, and then I'm going to give you another few minutes. I'm chunking it out again, like I said. I'm going to give you another few minutes to work. The probability of Jonas being late for school is 0.35. State the probability he's not late for school. All right, so instead of giving it to us as a percent, they gave it to us as a decimal number. So to find the complement, find the complement. Oh, that's too bad. I have something to tell you about that, though. I'll finish this question, then I'll tell you. Find the complement. See, that word complete is kind of found muddled up in the word complement. So when they don't give me, when they give it to me as a decimal number, I'm not subtracting it from 100%. I'm subtracting it from 1, because 1 is the highest decimal number we can get. That includes the whole set. So if I take 1, subtract 0.35, I get 0.65. Now, I guess you could have converted it to percents and found the percent, but since they asked me in decimal numbers, I'm going to respond in decimal numbers. So the probability, I'm going to kind of write it in probability form, of not being late equals, okay, now this time, they're not asking me in fraction form. If we go back to our chart here, right? For the previous question, they asked me in fraction form. They're asking me in decimal form. So I'm just going to respond in decimal form. Now, if you converted everything to percents and then you said 65 out of 100, that would be fine as well. Because they didn't specifically ask me to respond in decimal form, but I'm just responding as a fraction, or in the way that they gave me the question. Okay, so I'm going to stop for a minute and I'm going to give you a bit more time to work on the next chunk. So see if you can finish up number 8 and number 9 perhaps. Okay, I know that's a big one. Or actually, you know what? I'll finish number 8 because it's small, and then I'm going to give you time to work on those last 3. Let's finish up this page. Maurice hears that the probability of her brother's team winning the soccer championship is 8 out of 10. And the probability of the other team winning the champion is 5 out of 10. Is this possible? So the probability that her brother wins is 8 out of 10. The probability that the other team wins equals 5 out of 10. That doesn't seem possible, right? So if I convert this to a percentage, 8 divided by 10 times 100, this is 80%. And this would be 50%, right? 80 and 50 add up to be more than 100%. So, whoops, sorry about that. So this is not possible. No, this is not possible. If it's the same soccer match we're talking about, right? Because when we add the percentages up, we get more than 100%, right? And together they can't add up to more than 100%. 100% contains all of the data. So we can't have the two teams having more than 100% chance of winning something. So that's kind of tricky. That's pretty obscure, that concept, but that's fundamental to probability as well. If you're talking about the same situation and you add all the percentages up, you can only add up to 100%, which is how we found the answer to number 5, right? These two added up give you 100%. The 8 and the 12 added up give you the 20, right? The whole amount. So I'm going to leave that there. I'm going to get you, I'll just leave that there if you need it for notes. I'm going to let you work on the flip side, 9, 10, those are tough questions. Nice to hear from you, Cynthia. Yesterday, if you had internet problems yesterday, a lot of people had them yesterday. A lot of our teachers were saying they had problems. It was really super windy out. So I don't know if that caused any internet problems, but I know I had a hard time getting online as well. I had to start and stop twice before I got online yesterday. So that could have been part of your problem too. I'm not sure. I have a question for you though. I know there's two people watching, so I know Cynthia's one. I don't know who the other one is. So if you can hop into live chat, let me know. Cynthia, do you find that the video is clearer today than it has been? Or is it the same? Is it kind of fuzzy? I've been watching the playback and sometimes it's fuzzy. And I was wondering if today was clearer or not, or if you noticed a difference. I'm just wondering if you could let me know. That would be great. Okay, awesome. Okay, I borrowed a Chromebook from school. Super duper. Should have done this before. And I'm streaming from the Chromebook. So I'm hoping that that should solve a lot of problems. Good, good. I'm so happy. Um, I feel like I want to go back and re-record things, but that would take forever. Okay, that's great. I'm going to keep recording with the Chromebook too. And maybe that'll help because there's some lag sometimes, so I can rarely stay live anymore. That's okay, but it's almost always clear. Super. Okay. Super. All right. Did you finish the assignment, Cynthia? Okay. So I hope you don't mind. I'm just giving the class time to work. If you have any purple math questions, though, let me know, okay? And we can work on those too while I'm watching these. Okay, I'm going to take another 10-minute, give you 10 minutes to. Okay, yeah, and see if you ask me. And if you have time today, actually, let's do this Monday. I have something else that I'm going to give you, Cynthia, to work on Monday. I have a new program an online program that I think I can set you up with that might help you with the skills that you need for Red River. And I'll tell you all about it Monday. Can you hop online Monday at 10 o'clock, like 9:30, 10 o'clock with me? And I can set you up. I have something new for you. Okay, I'm just going to put my little note up just so everyone knows what's happening. Huh? You know what? Don't worry about it, Cynthia, then. If 10's too early, don't worry at all. Just come to normal class time and then maybe you and I, um, then I can talk to you maybe after class. Don't worry about it. Just show up at normal class time, okay? Show up at normal 12 o'clock class time and I'll talk to you about it then. Okay, I'm going to keep going. I'm going to attack those last couple of questions. These are the tough ones, right? I think. This gets into that whole, this is the last part of lesson 1. It gets into the whole thing about experimental and theoretical. Now, I'm going to say one more time, I know we talked about this yesterday, but this is how I define experimental. Experimental is what actually happened, like either from historical data that you've looked at in the past, or you just finished performing an experiment, or someone performed an experiment, and these are the results of the experiment. But theoretical is what should happen. Okay. Maybe this, what you think should happen. For example, in that coin toss experiment, if I flip a coin 10 times, because the theoretical probability of getting a head is 50%, if I toss the coin and it lands on heads, it's 50%, I would think that 50% of get heads 5 times and tails 5 times, like an split. But there have been times when I've tossed a coin and I've gotten all 10 tosses to be heads. So it kind of defies the theoretical probability. And that's kind of the beauty of life in a way, that it's a little mysterious. We don't really know what's going to happen, even though we have a good guess. Sometimes our good guesses turn out to be wrong. So let's take a look at number 9. Juan tosses a coin 30 times. Coin showed up tails 23 times. So 23 out of 30. That's a lot. State the experimental probability of landing tails. Okay, well, what happened was the probability of landing tails. This is how we tell the reader, I'm communicating, I'm talking about probability. Capital P stands for probability. The experimental probability, okay, what actually happened? 30 were tails. In theory, how many tails should I have gotten? Well, in theory, half of them, right? Only half? Only half would have been 15, but I got way more than 15. Explain the difference between your answers for A and B. Experimental probability doesn't always equal theoretical probability. And that's it. If Juan tossed the coin 1,000 times, explain what would happen to the experimental probability of landing tails. Well, right now the experimental probability is way higher than the theoretical. As you continue tossing, though, if you toss and toss and toss, what happens is the experimental probability becomes closer to the theoretical. If I tossed it 1,000 times, now what I expect is 500 of the tosses should be tails. Now, it'll be 500. If I toss it 1,000 times, I'll probably get like 500 or maybe 490. It might not be exactly 50-50, but it'll be really close to 50-50. So let's take a look at number 10. A vacuum manufacturer determines that 1 out of every 100 vacuums are defective. A large department store sells 100 of these vacuums and 10 customers return them because they're defective. What's the experimental probability? Okay. Well, this is I guess this first one, that would be the theoretical, right? They are stating that 1 out of every 100 vacuums is defective, but what actually happened, right? this is what actually happened. This is just their theory, their statement, but this is what actually happened. So what actually happened is 100 customers bought the vacuums, 10 of them were defective. So that's what actually happened. That's the experimental. So probability of defective would be 10 out of 100. Theoretical, the store says only 1 out of 100. All right. So I don't know, something went a little wrong with that store's testing, I think. But if they sold more than 100, if they sold 1,000 vacuums, what should happen is the number of defective compared to not defective should go down, right? It should start to approach 1 out of 100, you're hoping. Or the company could just be lying, right? I guess we don't know that for sure. And finally, number 11, a manufacturing plant is concerned with controlling the quality of its products. It is determined that the probability of producing a defective product is 1%. An employee checks 2 of these products from the manufacturing plant and finds that 1 of them is defective. Okay. The employee is concerned that the probability of the plant producing a defective product is now 50%. Explain the reasoning. Okay. So it is determined that the probability is 1%. Okay. That's the theoretical probability, right? Theoretical probability equals 1%. Experimental probability. Okay, so what happened was 1 out of 2 is defective. 1 out of 2, which would be 50%. Okay, well, that's why the employee is saying it's 50%. It's crazy. Should the employee be concerned? Well, they might be, but it's hard to say. So I'm just going to say it's hard to say right now. Now, 50% is cause for concern, but the sample size was so small. The sample size, like how many vacuums, or sorry, how many products the employee checked, the sample size is too small. The employee should check sorry about that, more than 2 products. They should check, I'm going to say like at least 100 products before they state the experimental probability. Now, what would happen if they just checked 1 product and 1 product was defective? Then they would say, well, 100% of our products are defective, and that's not true, right? So you have to make sure your sample size is large enough. Okay, well, that takes us to the end of assignment 1. Hopefully that gives people a little bit of clarity if some of the concepts were a little obscure to you. I guess we're at the end of class. I won't be able to start assignment 2, but I'm going to start that Monday. And Cynthia, I've got something new for you to do on Monday as well. So hopefully everyone has a wonderful weekend and enjoys the sunshine. So I'll talk to you on Monday.